Hello everyone and welcome to the NPTEL course in Pharmacognosy and Phytochemistry. In the previous unit, we dealt with drugs which contain fixed oils, fats and waxes. In this particular session, we will deal with different set of drugs and those are essences or aromatic oils, also known as volatile oils. So let's dwell into the world of volatile oils. So volatile oils are made up of components which are chiefly essential or ethereal or low boiling as compared to your fixed oils. If you see the components of it, they can be derived from two basic biosynthetic pathway. The first biosynthetic pathway is a shikimic acid pathway. The shikimic acid pathway is the pathway responsible for amino acids in plants, giving your tyrosine, phenylalanine as well as tryptophan, essentially your aromatic amino acids. This give you phenylpropanoid compounds, and few examples of phenylpropanoids are eugenol, which is phenyl, and you can see here 1, 2, 3 propane, as well as anethole. Again you can see a phenyl as well as a propane. So this phenylpropanoid derivatives eugenol is present in clove and anethole is present in your fennel fruit. If you see the other pathway, it's the acetate mevalonate pathway. Now this pathway is the one, if you remember in your biochemistry, responsible for sterol synthesis and has an intermediate called as isopentyl pyrophosphate or dimethyl allyl pyrophosphate. These are C5 compounds, often referred to as hemiterpenes. They dimerize to form C10, which are called as monoterpenes. An example of monoterpene derivative present in your volatile oil is your menthol. As you can see here, the component is a 6 carbon nucleus, and then you have your 7th carbon and you have your 8, 9 and 10. So 7 plus 6 plus 1 plus 3, that makes up 10 compounds. So this C10 is called as monoterpenes. If you add one more component of isopentyl pyrophosphate or dimethyl allyl pyrophosphate, you get C15 compounds, and C15 compounds are called as sesquiterpenes. A good example of aromatic compound which is sesquiterpene is gingiberine, which is present in your ginger. So as you can see here, this is very similar. So if you can cut it from here, it is almost similar to your menthol. Only thing what your menthol had is a non-aromatic 6-membered ring, but you can count here, this is your 10. So this is 1 plus 6 plus 7, you have your 8, you have your 9, you have your 10. Okay, so this is your 10 carbon, which is very similar to your menthol, and plus 1, 2, 3, 4, 5. So 10 plus 5 is your C15 called as sesquiterpene. Now distribution, you will find aromatic compounds. Now most of the things we see or feel in the nature have some aroma or the other. Some of them are pleasant aromas, some of them are unpleasant. If you go to see pleasant aroma, if you see the distribution of this, they are generally there in plants in form of fruits, in form of extracts, in form of leaves. They have a typical aroma associated. So this beautiful aroma you can find associated with Umbelliferae family, which is most of your spices, cumin, caraway, fennel, coriander. Rutaceae family, which has all your citrus family members, Rosaceae, the floral family members, and Labiataceae, which is your mint family members. Apart from that, you might have come across something which is very fragrant, such as vanilla. Right here is a picture of vanilla, which is a very expensive spice. If you go to see, it has a compound called as vanillin. Coming to animal sources, even animals are associated with aroma. Some of them are prized for it. The ones which are really prized are your musk, which comes from your musk deer, that is Moschatus mosciferus, and the compound is your muscone. Then you have your civet, which is obtained from civet cat, which is Paradoxurus hermaphroditus. Civetone is a pheromone which is present or which is sourced from an African civet. Then you have a whale vomit, which is actually a vomit but considered to be very fragrant and aromatic. The more it is aged, the more aromatic it is, and that's your ambergris, often referred to as your floating gold, which obtained from the sea. It's actually obtained from the digestive systems of your sperm whales. Now, chemistry of volatile oil, we can classify our volatile oil into two components, the components that are solid and the components that are liquid. The components that are solid are termed as stereoptenes. This portion or the solids which are dissolved in the oil owing to their lipid solubility or lipophilicity, as one may call it. Now, they generally separate once you start cooling the oil. So, the oil is no longer able to hold it, because decrease in temperature will lead to decrease in solubility and the solid components then precipitate out. Mostly there are oxygenated derivatives. A good examples of solids which are dissolved in volatile oil are your menthol and thymol. Now, the second component of volatile oil is your oleoptane. Oleoptanes are liquids, and these liquids are attributed to the aroma component of the volatile oil. It is generally said that as compared to stereoptane, your oleoptanes are more fragrant and they develop a good flavor. Example of this is from your citrus, you can think of limonene. From your clove, you can think of eugenol, or when you're consuming coriander fruit, you can think of the linalool flavor that is generally therein. Now, this volatile oils can be extracted, but their extraction methods differ as compared to your fixed oils and waxes. Fixed oils were generally obtained by expression, fats and waxes were generally obtained by expression and melting, sometimes solvent extraction. Now, volatile oils, owing to their volatility or owing to their vapor pressure, a different set of methods can be employed for purifying it. Few of them are discussed here. First one is steam distillation. In this method, you can just imagine there is a big pot, and from this pot you will get an steam being generated. Imagine a perforated basket, and on this basket whatever drugs, leaves, say for example mint leaves, eucalyptus leaves, whatever oil you want to obtain, all these leaves are kept here. Now, this vessel is closed so that whatever oil is being evaporated along with the steam rises up and then is connected to a condenser. Now, this condenser is thoroughly cooled, and through this condenser, or sometimes it is supported by a wet cloth, all the steam which is containing volatile oil is condensed in a vessel. On cooling, what happens is the steam will separate into a water phase and the volatile oil will separate into an oil phase. This oil phase is then collected, and that is how you get your steam distillation. Hydrodistillation, this water is not kept separate. You can see in here your water as well as your drug. Water as well as your drug is kept as it is. Now, what happens is the same thing, your steam as well as your essential oil both will rise. They will pass through this, rise up to the condenser and then come down. Now, as it is cooling down, it will form water and oil. So, this is water phase and this is what is the oil phase. Now, I am presuming your essential oil is lighter than water. There are exceptions such as clove in case where the oil is heavier than water, but let us study a case where oil is lighter than water. This is what is called as a Clevenger apparatus. So, what is going to happen as more and more of the solution condenses, this is going to overflow and the excess water will be recycled back into vessel. Over a period of time, more and more oil will be collected and you will get more and more oil. whereas the water will always be recycled back. For oils which are heavier than water, you can remove this bend. So what happens in this process when this bend is removed? We call it as a Dienstag assembly. So your heavier oil will locate or will be there at the bottom, whereas your water will always go on recycling from the top. Another method to do it is enfleurage, where you can keep a waxy layer, and especially for plants such as delicate petals, rose petals or flower petals who cannot be exposed to intense or harsh heat, in that case you just keep it in a fat layer, like dissolves like, so it will dissolve on the oleaginous matter including the essences. Rasping involves putting it in a bag or putting it in an assembly where it can be squeezed. Generally horsehair bags are used for this purpose because horsehair are non-adsorbent. So you squeeze it and remove as much oil as possible. In some cases even sponges are used to absorb it from the layer of your horsehair. Now pneumatic extraction is somewhere where you use a oven, and in this oven you have trays, and on one side of the oven a hot air fan is applied. As the fan blows, you will see a hot air moving, and this hot air will evaporate all the essential oil from the drug. This is then collected into a collecting assembly and condensed. This condensate on cooling will give you a nice quality oil. Another method, but these are non-specific method, they might extract components other than volatile oils as well, are solvent extraction. You can just take your drug such as cinnamon, clove, dip it in petrol or any lipophilic solvent to dissolve the essential oil, but it will also dissolve other lipophilic solvents, and then slowly evaporate the solvent. As the solvent evaporates, you are left with the residuals, and majority of that residuals is your essential oil. Also used in industry nowadays is something called as supercritical fluid extraction, where supercritical carbon dioxide is used as a solvent for extraction of your oils. Now chemical test, if I have to assess for the oils, I can either check it on the drug, that is through a section, or I can check it on the powder by performing a chemical test. Now microchemical tests are generally non-specific, that means they can detect either volatile oil or fixed oil. So let's take an example, say so for example you have a clove, and in that clove, on this particular clove you have your oil glands. This is filled with volatile oils. What you do is on your clove you add your Sudan red solution. What will happen, Sudan red is an oil soluble dye, so it will dissolve and it will be solubilizing and being red in color all your oil cavity. The Sudan red will disperse uniformly, giving you a red color stain. But the problem of this test that even fixed oils dissolve the Sudan dye. So even if the drug contains fixed oil, you will see the same phenomenon happening. Same way, like your Sudan red is another dye called as Alcana, which contains naphthoquinones alkanin. They have a good oil solubility and perform or behave in the same manner, but rather than a red color, you will observe a maroon to magenta coloration. Now this is obeyed by both fixed oils as well as volatile oils. Now coming to specific tests, what you can do is a chemical test. So take your drug which you feel contains essential oil, extract it in a lipophilic solvent such as chloroform, and then you carry a staining test on filter paper. So drop or put few drops of it on the filter paper. If the stain disappears along with the solvent, there is a good chance that your drug contained volatile oil. But as the solvent disappears, if the stain still remains, that means your solvent has dissolved a fixed oil. The next test what you can do is same chloroform layer, you can treat it with vanillin and sulfuric acid. It is said that your terpenes react with vanillin sulfuric acid to give you a reddish color complex, and that is one confirmatory test you can do to check for volatile oils. Now coming to examples, let's discuss an example of clove here. Now clove is one of the most commonly used spices. It is referred to as Syzygium aromaticum or Eugenia carifulis, belonging to the family Myrtaceae. what is used from this plant is a flower bud. Okay, you can see a flower bud here. So this is a typical stalk. We call it as hypanthium. This is the sepal. And this is the corolla part, the petal part of it, but because it is unopened, you can see each petal here. You can see a nice border here. So this is the petal. If you take this out, this is called as crown. If you take out the crown, you will see anthers below it. Okay, so this unopened buds are generally what is used as drugs. Now this grows mostly in tropical regions of Africa, chiefly the islands such as Zanzibar, Sumatra. You might find it in Madagascar, Mauritius, West Indies, in India, and as well as Sri Lanka. So these are the chief producers of clove as well. Clove is generally taken out or harvested from plants which are like 6 years old, and as they age they keep on yielding till as much as 70 years old. So if you say clove oil, clove contains almost 14 to 20% oil, which is very high content, and it's there both. So if you see here, it's there in the stalk, that is the hypanthium, it's there in the corolla, it's there in the sepals, it's there everywhere, and that's why we take the whole plant here. So it contains 14 to 21%, of which chief is the eugenol. If you see eugenol, this is again a phenyl propanoid derivative, and then which is almost in some cases 90%, but if you see on an average it is 60 to 90%. Most of the analgesic properties or painkiller properties of clove are attributed to eugenol. In addition to it, it contains other sesquiterpene derivatives, and these are your alpha and beta caryophyllene, chiefly your beta caryophyllene. Now this is your beta caryophyllene, which is the major. Sesquiterpenes means it contains 15 carbons. So these are almost similar, the only thing is this is cyclized. Okay. In addition to that, it contains tannins such as gallotannic acid, it contains acetyl eugenol, it contains furfural, methyl furfural, little amount of gum, resins, and lot of fibers. So this all in all gives you antiseptic properties. If you see a way to evaluate clove, if it is good, you can just press the hypanthium, you can see some oil oozing it, or you can take a section and add some potassium hydroxide into it. You will see that this potassium hydroxide will convert the eugenol into potassium eugenate, and you will see the needles in the oil cavities. If you want to do a chemical test, what you can do is you can take the clove oil, dissolve it in alcohol, and then add a drop of ferric chloride. Alcoholic ferric chloride, you will see a blue coloration which is attributed again to the phenolic group of eugenol. Coming to the uses, clove has numerous uses from traditional to modern day. It is used as antiseptic, stimulant, carminative, aromatic, also as a flavoring agent, a condiment, as a spice. It is used traditionally for stopping toothache. People generally take a clove bud and keep it between their teeth if they are having a toothache, or as a precautionary measure or as an anodyne. It's also anti-emetic. Dentists also use clove oil especially for root canal treatment when they have to disinfect the area, as well as because it acts as a local anesthetic. It works two ways. It kills parasites, it has good antimicrobial and antifungal properties. So it's also used in internal applications such as treatment of diarrhea, worms. It is also used to manage local or what are called as digestive ailments. It is strong germicide, and people often give clove oil as to kids, a drop of it as an expectorant to deal with bronchial issues. So these are few applications, but if you see modern day literature, more and more clove uses you might come across. Now going to the next herb is mint. Now mint is not a single herb, it is actually a collection of plants or perennial herbs which are belonging to the family Lamiaceae. Now these are wide spreading, what you can say, overground stems, and the chief ones in market are your peppermint and spearmint. But if you see the species and variants of it. Mainly you'll see Mentha aquatica, arvensis. When I'm saying these ones are the pure ones, Mentha cervina, but if you see X out here, it means it's an hybrid. So Mentha gentiles, Mentha longifolia, Mentha piprata, that is your peppermint, is a hybrid. It's actually a hybrid between Mentha spicata, which is your spearmint, and Mentha aquatica. So you will have your Mentha puligium, Mentha spicata, again a hybrid Mentha villosa, Mentha requilini, and numerous others. So there are numerous Mentha species, but let's discuss two here, and that is your peppermint and spearmint. Now coming to peppermint, it is obtained, or peppermint oil is obtained by distilling the leaves which are obtained from Mentha piprata belonging to the family Labiataceae. Now mints have been cultivated in Europe, US as well as India. Peppermint, you will find it abundantly growing, and nowadays it's cultivated because of its food application chiefly. So these are very easy to propagate. In fact, it's a very aggressive plant. So what you need to do is just dig the runners in the early spring and just lay them off little away, that's like 2 or 3 feet apart, and then you will find that during summer they'll all spread, they'll be full bloom, and when they are ready you can, or when they are in the flowering stage, you can cut them off. It is also observed that during the dry season the oil content is higher, so that is also an advantage and reason why it is harvested during the summer season, because moisture is less, the oil is more, so the yield is more. So once you obtain this is generally done by steam distillation. As discussed earlier, you might get a yellowish or a greenish color liquid depending upon the method of preparation. It has an intense penetrating odor, and if you go to consume mint oil, it has a burning sensation, and this burning sensation is followed by a very stinging cool flavor, and that's attributed to its chemical compounds, which is your menthol. Your L-menthol is the natural element which is present in your mint oil. So peppermint oil contains chiefly L-menthol with other menthol derivatives, menthone, isomenthone, methyl acetate, isovalerate, cineol, limonin, and other compounds. Now menthol is a stereoptene, that means it's going to be a solid. So if you take the mint oil and start cooling it, once the temperature goes below -22 degrees Celsius, you will see on the sides of the flask menthol starts depositing as tiny crystals or tiny white powder. So you can separate it out by taking the temperature further down, and what you get is a separated menthol and a separated oil. This oil is called as demantholized oil. This is used as flavor. Menthol is chiefly used as a cooling agent. So if you think your peppermints, especially your polo or pudin hara, you might have consumed it, that has a stinging sensation or cooling sensation. That's because of menthol that has been added. So the flavoring properties are due to both esters as well as alcoholic. This is alcoholic, whereas methyl acetate is an ester, whereas the medicinal value, if you go to see, is more attributed to alcohols. Now there are different variants of mentha. The English oil, if you go to see, contains 60 to 70% menthol. The Japanese one, generally called as the mentha arvensis, gives you as high as 70 to 85%, whereas American oil contains little less, about 50% menthol. If you want to separate it, the Japanese one is the best source in all. Now coming to applications, the most common application is flavoring agent, and if you can see here, I have just put a few emphasis. If you see, this is your natural L-menthol. Now menthol is also obtained synthetic, but what happens is when you do synthetic, you often end up getting racemic mixture, and racemic mixture has slightly dull flavor as compared to the natural one. Now you can see here there are numerous attempts to increase the cooling sensation and increase the residual time of cooling. This has been done by using amide linkages. So to that menthol, amides have been prepared, and few derivatives such as Wilkinson Sword WS3 derivative or Evercool 180, which have many fold cooling properties as compared to menthol, are already in market. If you see the pure mint oil, it's used as a stimulant, stomachic, carminative. It's used to manage flatulence, colic pains, in some cases dyspepsia, sudden intestinal pains or cramps in abdomen, and also in cases of cholera and diarrhea. Now peppermint in some cases for people those who feel nauseous or have motion sickness, peppermint oil is known to allay this. It is also good for people who want to raise the internal heat and induce perspiration. And like I said, majority also goes in your food industry, and in cosmetics nowadays you find soaps, deodorants containing menthol for giving you that cooling sensation. Now the other species which is mostly used in your chewing gum is your spearmint, and that is obtained from another species of mentha called as Mentha spicata, or also called as Mentha viridis. This is also a Laminae family member and most abundantly found in Europe and southern temperate Asia. It's also cultivated in the regions from Ireland to China. Now the difference here is, there we said or discussed species which had a very high content of menthol. Here if you see your spearmint, instead of menthol, the active component is carvone. It's a ketone, not an all, and the composition is as high as 50 to 80%. So it almost replaces the menthol from Mentha piperata with your carvone, and that's the reason your chewing gums don't have a intense stinging flavor, but they have a very mild sweet flavor, and that's not menthol, that's your carvone. Apart from that, it has your transcarviol, pipritone, limonene, cineol, camphene, paracymene, dihydroxycarvone, pugilone, caryophyllene, germacin, which is also being explored nowadays, menthone, alpha-pinene, and linalool, which also attributes the sweet aroma. Now all of this, once you prepare or get the dementholized oil also has numerous applications. So it's used in food. Like I said, if you take menthol, it has a stinging cooling sensation. If that is gone, now it is more of a sweet cooling sensation, and that's the reason dementholized peppermint oil has been used in pharmaceuticals, cosmetics, foods, beverages, Ayurvedic medicines, because in some cases people are sensitive to menthol. So if you consume or if they consume menthol product, that leads to sneezing or irritated mucosa. So dementholized oil offers a better alternative for treatment for common cold, cough, flu. It is nowadays also used in soaps, body lotions, deodorants, creams, also in shampoos, because the dose of menthol is minimal, so the irritancy, itching or stinging sensation is not there. Apart from that, it's also used as a mild agent in food and flavoring, especially beverage industry. Now what we do is, in some cases, the essential oils, we saw that lipids and fats rancidify, but volatile oils, they polymerize and they form resins, and as a result they lead to loss of aroma. In order to enhance the shelf life, we prepare what are called as terpeneless volatile oil. This have been obtained by fractionation, wherein the low boiling fractions have been removed. So most of the hydrocarbons from this oil are removed, and as a result these are more rich in oxygenated products. So once they become rich in oxygenated product, they become more stable, they are highly soluble in alcohol, and their aroma profile increases. So terpeneless volatile oil are more better concentrates than the native essential oil to be used in perfumery, to be used in foods for flavoring purposes, and in the pharmaceutical industry. So here are few references that you might want to read for additional knowledge, and thank you everyone for your patient listening. Thank you.